Today we'll be covering 4.3, which is on solving quadratic equations with square roots. And so we'll learn how to get an exact answer, and we'll also learn how to get approximate answers. And so those are our two goals for this unit. All right. And so a couple of things to keep in mind. When I talk about solving, and we keep talking about solving, and we're talking about like, where does that U cross the x-axis? So we're talking about these x-intercept points, and they can be a positive and negative. It could have crossed at positive 1 and negative 6. So it can be lots of different values. But the whole idea, or maybe it doesn't even cross the x-axis at all. So maybe it's up here somewhere. But when I'm solving, that's what I'm looking for, is where does it cross the x-axis? And so as we look at this whole idea of, if I can get this to make it bigger. When I look at the whole idea of solving a squared function or a quadratic function with a square root, a couple of things come into play. One is if the squared term, we're going to isolate the squared term. So we have these steps here. So the first thing we want to do is isolate the part that's squared. The second thing that we're going to do is we're going to take the square root of both sides. And then the third thing that we're going to do is we're going to simplify. So those are our steps that we need to go through. Now, when I do those things, a couple of things can happen. When I have this squared term, whether that's a letter squared or parentheses squared, the number that's it set equal to, once I isolate it, determines a couple of things. If this number is greater than 0, so what that means is this is a positive number, then what happens is I end up with two real solutions. I get a positive of that number, pretend that didn't cross off the D, and a negative of that number, okay? If D is equal to 0, is what it is, then you get one real solution. And then if D is less than 0, which means the value that you have it set equal to is negative, then you have no real solutions, which means that your solution is going to have an I in it, okay? Whatever that happens to be, okay? And we've worked with I already in 4.6. And so you are going to see that today. And that's fine. We already know how to deal with a square root of a negative number. So we should be fine. So again, our steps are isolate the square term, take the square root of both sides, and then simplify. So as I look at example 1, I look for the square term. So this is my square term, and I'm trying to get it by itself. So I'm going to add 27 to both sides. And so I get 3x squared is equal to 27. The next thing I need to do is I need to isolate the squared term because it's not all by itself yet. It's getting there, but not quite. So I have to get rid of this 3. So the way I get rid of the 3 is I'm going to divide it because it's connected through multiply. So I'm going to divide by 3, divide by 3. And so this gives me x squared is equal to 9. And then the last thing we're going to do, and that's where, so we've done step 1, isolate the squared term. The last thing that we're going to do is we're going to take the square root of both sides, I guess second step. Square root, and we get x is equal to, notice that this is a positive 9, and so if it's a positive 9, we get two real solutions. Now, right now, it kind of looks like we don't have two real solutions, but anytime that you draw the square root sign, we also need to remember that that means positive or negative. We don't know if it was a 3 times a 3 that gave us a 9 or a negative 3 times negative 3 that gave us 9. So we have to take into consideration the both the positive and the negative of that solution. So the square root of 9 is 3, which means that my solutions are x equals 3. There's one solution, and x equals negative 3. That's our second solution. Now, if I look at problem B, same idea. First step is still to isolate the squared term. So here's my squared term. I need to get rid of minusing 10 by adding 10. So I get x squared is equal to negative 10 plus 10, which is 0. So there's step 1. Step 2 is we have to take the square root. So I square root, x is equal to, I drew the square root sign, so I get a plus or a minus, and the square root of 0 is 0. 0 is not positive or negative, so I get one real solution of x is equal to 0, which remember we said if my d value up here, if my d value is equal to 0, so when I get squared isolated, if it's equal to 0, I get one real solution, which I did. Okay, I get x equals 0, and that's always going to be the solution. And then our last thing is we're going to, again, our first step is isolate the squared term. So here's my squared term. I'm going to subtract 11 from both sides. So I get negative 5x squared is equal to 5. And then again, my squared term is not all alone. So I'm going to divide both sides by negative 5. And now I get x squared is equal to negative 1. Now, again, if we looked back up there at the top, as we looked at our rules, we said, oh, if this d value is negative, it means I get no real solutions, which means I'm going to have an I. So to undo the 2, I'm going to take the square root of both sides. So we get x is equal to plus or minus, because I drew the square root sign. And then we have to remember the square root of a negative 1 is I. And then I'm done. And so my solutions then would be x is positive I and x is negative I. These are not real solutions because you have I, but they are still a solution. All right, so as we look and move on to example 2, notice that it looks a little bit different. Now you have parentheses squared is equal to 25, but my steps are still the same. As I look at this problem, and I ask myself, is the squared term isolated? Well, this is my squared term, and it's already by itself on the left-hand side. So yes, it's isolated. So then I move to step 2, which is how do I get rid of the power of 2? Or step 2 is take the square root of both sides. And so we get x minus 1, because that just makes the power of 2 go away, is equal to plus or minus, because I drew the square root sign, and the square root of 25 is 5. That plus or minus is the 5. It's not anything else. That's a positive 5 or a negative 5. And now when I go to solve this equation, I'm trying to get x all alone. So I'm going to add 1 to both sides. And something to keep in mind, this 1 is a positive 1. The plus or minus, like I said, is attached to the 5. So I have to do plus or minus 5. The plus or minus just doesn't go with whatever number I want. It always goes to the number you took the square root of. And then what happens is it breaks down to 2 problems. 1 plus 5, which is 6, and 1 minus 5, which is negative 4. And so my 2 solutions are x is equal to 6 and x is equal to negative 4. And right underneath it, it just talks about if you were to graph this, you're going to see that this u crosses at the point negative 4 and positive 6 if you were to count it. And so they're just saying, well, even if you weren't able to, or if you wanted to see if you were doing it right, if I graphed it, I would be able to see that U shape and see that it crosses at those 2 points. Okay, so this is monitoring progress. So let's go over a couple of these. If it was me, I would take a pause your video and do a couple, make sure you're good. I would definitely do maybe a 1, 5, and 6, and go ahead and do those really quick. Whoops. So if I was doing this, I would divide both sides by negative 3. So this gives me x squared is equal to positive 25. And then I've isolated the squared term, so I take the square root, and I get x is equal to positive and negative 5. So if I was to put it in the computer, I would have x equals 5, x equals negative 5. From now on, I will just write plus or minus, unless I can go further. So here I can subtract 12 from both sides. So I get x squared is equal to negative 2. Again, my squared term is isolated, so I can take the square root. So this gives me x is equal to plus or minus. This is the same thing as negative 1 and 2. I saw a lot of you guys on your quiz did this step of breaking it down as a negative and a positive, but then you forgot that the whole idea, the whole reason I do that is because this is equal to I. And so then I comes out. 2 didn't have a partner, so he stays underneath the radical. And so my answer then would be x is equal to I root 2, and x is equal to negative I root 2. 3 and 4, when you add your value over to get this thing isolated, you get 0. So you end up with x equals 0 for both of those. But I'm going to jump down to 5. So we're going to take the square root, or we're going to isolate the square term by dividing both sides by 4. So this gives me x minus 3 squared is equal to 9 over 4. And you can divide that out as a decimal if you want to. I usually just leave it as a fraction. Take the square root, take the square root. So you get x minus 3 is equal to plus or minus. The square root of 9 is 3. The square root of 4 is 2. So we, again, plus or minus because I drew the square root sign. And now we're going to do the whole idea of I need to get the x by itself. So I'm going to add 3. And again, we get x is equal to 3 plus or minus 3/2. Whether you're doing that with your calculator, either one, I don't care. But this ends up being 2 problems, 3 plus 3/2 and 3 minus 3/2. And you need to actually, because those are both normal numbers, you actually need to do out the work. So 3 plus 3/2 or 3 plus 1.5 is 4.5, and 3 minus 1.5 is 1.5. And I can just put that in my calculator to get my answer without a problem. Okay, but you can't just leave it as x plus 3/2 and x minus 3/2. If it's regular numbers that you can combine, you have to combine them. And then our last one, I'd take the square root of both sides. So this gives me 2x plus 1 is equal to, again, plus or minus 6, because I drew the square root sign. And the reason I can jump right to taking the square root is because the parentheses raised to the second power are already isolated. And so I'm going to subtract 1 from both sides. So this gives me 2x is equal to negative 1 plus or minus 6. So really this turns into 2 problems. It's 2x is equal to negative 1 plus 6, and 2x is equal to negative 1 minus 6. And then you can go from there. This is 2x is equal to negative 1 plus 6 is 5. And then you can divide both sides by 2. So then x is equal to 2.5. And then over here, you get 2x is equal to negative 7, so that when you solve from there, you'll divide both sides by 2 to get x is equal to negative 3.5. And again, make sure you're doing that out all the way. You can't just leave it halfway done. All right, when it talks about approximating, what that means is that it didn't come out beautiful. Okay, so when I go to take the square root, it doesn't come out as a beautiful answer, which is fine. But it will usually tell you what place value to round it to. But other than that, everything else is the same. My equation is 4x squared minus 13 equals 15. My first step, just like before, is we isolate the square term, which is here. So we're going to add 13 to both sides. So we get 4x squared is equal to 28. And the next thing I'm going to do is I'm going to divide both sides by 4. So you get x squared is equal to 7. So now we have the isolation of the square term, which is what I want. To undo that, we take the square root of both sides. And then again, because I took the square root, sorry, I wrote too big. Because I wrote the square root, I write plus or minus, and then 7 is prime, and it doesn't come out as a nice number. So I get x is equal to root 7, and I get x is equal to negative root 7. Now, because it tells us that you don't want a radical answer, basically, it says round to the nearest hundredth, then I just put that in the computer, or the calculator. And you're just going to go the square root of 7, which is 2.65, and the square root of negative, or the square root, negative times the square root of 7, which is going to give me negative 2.65. And again, if you're not sure, you just put it in the calculator, second x squared, put it in. For monitoring progress, let's just do one of those really quick. Let's just do number 9. So we're going to add 30 to both sides. So this is going to give me 3x squared is equal to 34. Again, the isolation of the squared term is what we are going for. So we're going to divide both sides by 3. And so when I divide this out, 34 divided by 3 does not come out as a nice number. It's actually kind of gross. It repeats a 0.3. And so what we're going to do is we have the isolation. So we're going to take the square root of both sides. And so we get x is equal to plus or minus the square root of 34 over 3. And again, all I do is put that in the calculator exactly the way it looks. And you'll get x is equal to, I forgot to share my screen the right way. So you're just going to have to trust me. But you're going to do square root, and you'll just do 34 divided by 3 in your calculator. And it's going to give you plus or minus 3 and you have to round to the nearest hundredth because it tells us that. And so the third number is a 6, which is going to bump our 6 up to a 7. And so it would be positive 3.7 and negative 3.7. And then I just wanted to talk about one more. I'm just adding it on just as a reminder. If it's not by itself, okay, so in this case, I don't have it by itself, so I'm going to have to get the squared term alone. And this gives me x minus 3 squared is equal to 8 minus 2, which is 6. I've got the squared term by itself, so now I want to take the square root. And so I get x minus 3 is equal to plus or minus root 6. Okay, 6 does not come out as a nice number, which is fine. There's not an issue with it. You just need to remember that when I go to solve this, this is x is equal to 3 plus or minus root 6. And we'll talk about this again in the next lesson, but this is going to be 3 plus root 6 and 3 minus root 6. Those are going to give us 2 different answers, not a positive and a negative of the same answer. And again, I apologize for not sharing my calculator, but it's going to be 3 plus root 6. And you just put it in the calculator exactly that way. And if you round it to the hundredths place, which is usually what it asks you for, then we get 5.45. And if I do 3 minus root 6, then I'm going to get 0.55. And so notice that these answers are not close to each other. One's not positive and one's not negative. So you need to make sure that as you do problems like that it's okay to get 2 separate answers. I know it looks like most of your answers are one positive and one negative. That's not always the case. It's just based off your problem. Example 4 is just a real life problem. This is our height, and it talks about writing an equation for the volume. And what we have to remember is the volume of a rectangular prism is length times width times height. And it tells us what the volume is. And so we're just going to substitute in what we're given. And so we know that the volume is 270. We know that the length is 3W. We know the width is W. And because we don't know anything there, it doesn't give us anything. And we know the height is 3. And so what I'm going to do is just solve that equation. So I get 270 is equal to 9W squared. And now we're back to a normal problem, even though it seems like it's real life and it might be hard. Now we're just back to the normal. I isolate the squared term, which happens to be on the right-hand side this time, but that's okay. We divide by 9. And so I get W squared. I'm just going to flip it across each other. 270 divided by 9 is 30. And now we're going to take the square root. And when I take the square root of both sides, because I wrote the square root, it's a plus or minus. That part didn't change. All right. And yes, I could break it down and everything, but 30 is not a perfect square. So I put it in my calculator. And what that does is I do square root of 30 and negative square root of 30. And that's going to give me an approximation value. And so when I find the square root of 30, in this case, I will have one positive and one negative. But the difference here is, can you have the width be a negative value? And hopefully in your head, that makes sense that doesn't make sense, hopefully, right? You can't have a length be negative. And so that one didn't work out. So this is my width. And again, is that your answer? Well, kind of. Remember that the question was, what is the length and the width? And so in order to find the length was 3 times the width. And so we're just going to go 3 times that number to find out what the length is. And so if I do 3 times that number, I'm going to get 16.44 about. All right, and so that's what it's asking for. So the dimensions of that pool would be 5.48 by 16.44 by 3. And that's all example 4 is asking you to do. And that's pretty much it for 4.3. So hopefully that makes sense. Let me know if you have any questions.